Hello. Hello. So please, please, use your clicker or personal response software. Interesting. So, if you've seen my email already, this is the average for the exam. What is it here? It's a little bit lower than I expected. The actual is a little bit higher because this average includes 2 zeros, which are not supposed to be in there. And another thing is that if projected, assuming in the future nobody loses any points on anything, so the projected final grade still looks kind of good. So, like the first page of the Hitchhiker's Guide to the Galaxy says, don't panic. We'll see how it goes. My assumption is, and that assumption based on all my experience, the final grade depends on, well, this calculation. There are many factors in life which affect our performance on the exam, at work, at home. So everything boils down to this ratio, and whatever happens in the skies. What I saw is that some students showed work which, from my point of view, is a clear indication that those students didn't actually spend much time in this room. Because there are some elements of the exam which are designed to, well, see how people work during this interval, Monday, Wednesday, Friday, 2 to 3. And everyone, including myself, who not completely satisfied with the grade, well, first of all, again, that reminder, the sources for the problems come from, well, everything. And normally, I don't recommend trying to predict, trying to guess what kind of a problem might be or might not be on the exam. So the best approach is trying to develop the problem-solving strategy for every kind, for every type of a problem. Now, the problems which have been chosen not in 100%, but 97, 93, 94%, depending on the problem, similar to the problems which have been done in the past. And this problem, that's a discussion. That's a lab. So what might be useful in the future when doing the homework or when refreshing what has been done in lab or discussions, trying to extract some specific features of different situations which help to recognize what kind of a situation is, well, presented here and now in this particular problem. So the first step of any problem-solving strategy is recognition. And if our brain recognizes the situation, that's it. We relax and we do it. If our brain doesn't recognize, we panic. And another thing to practice is to calm down and try to walk through that recognition process. So every problem has a special problem-solving strategy, and the second test from that point of view is indeed a little bit harder than the first, because to solve 6 problems, well, 8 problems actually, 8 problems on the first exam, we need to use only one strategy, Newton's second law. Here, 6 problems, but they use different strategies. So the list of the strategies should be kind of used. Yeah. Second law, still one of the possible strategy, but also second Newton's law for rotational motion, another strategy. Law of conservation of mechanical energy, third strategy. Law of conservation of linear momentum, fourth strategy. Torque balance equation, fifth strategy. So in this, of course, from that point of view, if we need to use more different strategies, so we have to choose from more different choices, it makes reasoning process slightly more complicated. Plus, again, as you can see right now, out of 105 students listed on the roster, we have here 79. So let's round it up to 80. 25 students are at higher risk to not recognize the proper strategy and to not use it on the exam. And again, from my personal experience, I would expect the correlation between the lower grade and the number of missing lectures. All right, that's a formal part, not related to we're going to study in a minute. So any questions? Yes? Can't hear you. Cannot hear you. Again, and before I forget, other questions, please. suggestions. Because the result which I see here, not really what I've expected. I've posted a survey, anonymous. So the more information you give me back, the more information I'm going to process. Because we still have one more exam left ahead of us, which is not accumulative from a formal point of view. But in reality, kind of is. Still, some of the parts of the physics might be related to the application of the Newton's second law for translational motion, or even for motion with constant acceleration. Yes? Yes?
Yeah, I was wondering if there will be any sort of curving for anything in this class.
I don't curve. First of all, when I look at this, I don't really see any need to make any adjustments so far.
What numbers did the letter grades correspond with?
I don't remember. The first page of the syllabus tells you general. Normally from 90 above, it's A and minus. 85 to 90, B plus, B, B minus. But again, you should re-watch the very first lecture because I've given some information on how the boundaries are being drawn, and there's sometimes shift one way or another depending on the final grade distribution. Yes? Could you please, someone, I don't understand the question.
So you're not going to turn him to all about 100 on the next.
No, I don't curve. But if I need, by some reason, to make an adjustment, I have tools.
Is she saying that the distribution for the max grade right now is not going to be realistically what it will end up?
That's why it's called maximum.
But that's not really making it.
It depends, You see, what tells me that this exam was a little bit harder than I meant? This number. A good exam should have at least 140, 100%. That's a good exam, properly prepared. So, but again, preparing an exam is not a science, it's a lot of art. So if I had exactly 40 here, I wouldn't even think about anything. 39.25, well, maybe I overlooked some elements. I'm not sure yet, actually. So I'm still waiting for your feedback, anonymous feedback, or I haven't read yet your after exam feedback pages. I'm going to do it again over weekend. We'll see. But this distribution, as my email says, based on the fact that from now on to the end of the course, nobody losing any points on anything. That's why it's called max. That's why it's kind of important to review your previous strategy and maybe make adjustments or maybe suggest what kind of adjustments in the future should be made. You know? What went not as planned, basically. That's what everybody should rethink. And trying not losing any points for anything, including the final exam. The final. It's a percentage problem. You take the first page of the syllabus, it gives you all the percents. You enter the equation in the spreadsheet, and you play with your numbers. And you can see, and that's actually what I did. So I know possible distributions, several possible distributions, not just the maximum, but other possibilities. And you can do the same. You can try to predict what kind of a grade you may have if your final exam will not be 40, but will be 39 or 37. Plus, well, homework problem normally not a problem for majority of this class. Only a few students, by some reason, have lost relatively large amount of homework points because of not doing it. I'm not sure why again. I don't know. But for students who actually doing homework, all comes down to that final exam. Yes?
So for the people who did their homework on time, isn't it unfair that you're giving an extension for people who didn't do their homework on time? So could we possibly get extra credit?
No matter what I do, it's going to be unfair for someone, one way or another.
But you put a deadline when people didn't complete it.
To everyone. People who didn't do the homework on time being punished automatically because they're not prepared for the exam as good as they could have been prepared. And sometimes I do things, sometimes I don't things. Again, it's not an exact science. I felt, well, I have feelings. I felt something. We all do, so. But nobody cares about it in real life. Not your boss, not your colleagues. That's why we call it life. Moving on. One more thing. Of course, every time I've got 1, 2 emails asking for a personal meeting. I don't do that. I don't curve. I don't meet personally. I have office hours. If you can't find me during office hours, catch me here, but it's not going to be closed room with no witnesses. That's it. If you want to discuss something, do it openly, or send me an email. In that case, there is a record of communication. Again, can't hear you. No, I'm not going to curve the exam too. Moving on. Any questions? All right. I want to save it for history. And what is the number 3 answer? Me too. All right. All right, all right, all right, all right, all right, all right. Okay. Let's do physics. So we know the answer. See? No. How do I do it? No. I need this space. Now let's actually see it. Seeing is believing, right? All I need is a long ramp. Actually, probably. All right, as long as we can see the board and the finish line. And of course, we're going to solve it mathematically. Almost frictionless cart and a sphere. Well, so this is the starting point. Well, we knew that the frictionless cart would win this race. Now, let's prove it mathematically. I will be using the law of conservation of mechanical energy for almost all problems related to rolling because it's much easier approach than using Newton's laws. I will show one example in the future. So, sliding down. Well, of course, there is a potential energy. If we measure it from the bottom of the ramp, the potential energy is equal to mgh. And if we release it from rest, there is no kinetic energy. And if there is no resistance, non-conservative forces don't do any work. And when it's at the bottom, when it's reaching the bench, the floor, now potential energy is 0. But kinetic energy now, what? Is just this. Sliding means translational motion, and we can cancel m, and we can solve it for speed, and that will give us this. That's exactly what you've done, everybody who came to the discussion done already. So it's, again, kind of review. Just make sure everything is clear for everyone. And now, a sphere. It actually doesn't have to be a sphere. It could have been a cylinder, a ring. So all I know is that it rolls, so there's a moment of inertia which equals to some number times mass times the radius squared. That's the moment of inertia about this axis. So it starts from the same height. So it has the same potential energy. It starts from rest. So it has no kinetic energy at all initially. At the bottom, it has no potential energy. Again, measuring from the lowest point as we always do. But kinetic energy now should include two terms. The first term is responsible for the motion of the center of mass. And the second term is responsible for the rotational motion about the axis, which is passing the center of mass. And now we can simplify this. mv squared over 2 plus. Well, this coefficient, the capital C, we call it a form factor. The first factor, then the mass, it's the same mass, then radius squared. And now it's very important because there is no slip-in. Yeah? It doesn't do anything like this. So there is no velocity of the lowest point of this sphere relative to the ground, relative to the board, which means the motion of the center of mass is coupled with the rotational motion. We know how. We know that, for example, the angular speed about the axis, which travels through the center of mass, is related to the linear speed of the center of mass by this expression. So we can use this expression. Well, let's use the same capital R in all equations. And turns out that, first of all, again, this cancels. The math doesn't matter. What matters is the shape. Yeah? This number, form factor, matters. And what else? This cancels. R squared, R squared. So we can simplify this expression. What's left is 1/2 inside, so v squared, and inside it's 1 plus that capital C, that the form factor. So now we can solve it for the speed of the center of mass of this ball at the bottom of the ramp. And that's going to be equal to, again, 2 times g times h. But now it's going to be divided by 1 plus the form factor. And we need to compare. No. It's a form factor, not a fear factor. A form factor is a name for this C. It's a number which depends on the form, on the shape. We don't call it shape factor. We could have. Its official name is a form factor, but it means it depends on the shape because different For the sphere, it's a 2/5. For the disk, it's 1/2. For the hollow disk or for the ring, it's 1. That's what it is. It depends on the shape, on its form. That's why we call it a form factor. So, and for this coefficient, for the form factor, no, that's not what I want to. This. It's a positive number. It's a positive number. For the, well, this has no form factor. For the sliding object, it's equal. It's 0. It equals to 0. But if anything rolls, that's not 0 anymore. That's some positive number we are adding to this. So any rolling object ends up having lower speed. There's a 2gh, 2gh, same part, but now you have to divide it by something else. So, well, the last part of the reasoning is this one. If they travel same distance, initial speed is the same for both is 0, but the final speed is different. So this is equal to this, and this is equal to this. The fastest, the easiest way to relate, because it's motion with constant acceleration, the distance traveled should be equal to speed over time. Yes or no? No. Time over speed? Okay, yes or no? Just tell me. I don't want to spend time on polling this. So speed times time, is it a correct expression which relates distance traveled, time, and speed? No. No. That's the motion with constant acceleration. Its constant speed constantly changes. That's average speed times time. Is that what it is? But to answer this question, it doesn't matter, because the average speed equals initial plus final divided by 2 times time. So if we want to compare the time, we just have to solve it. Time will be equal to this times this divided by final speed. So, and here, that's going to be exactly same relationship. Because distance is the same, everything depends on this. If, well, if this is a larger number, that means it takes less time to reach the finish line. So that's why it finishes first, and the sphere finishes second in this race. And again, if we go, so we don't have to do this math if we just look at these two equations. They start having exactly the same amount of energy, mgh. But for the sliding object, that energy getting transferred into its motion. But for the rolling object, only part of its energy goes into its motion. Another part goes into rotation. So that's why it loses. And this is a question I want to ask you now. It's again about a race. But I'm not going to race a sphere and this frictionless cart anymore. I'm going to race these three objects together, a hollow disk or a ring, a solid disk, and a sphere. And they all have, you see, pretty much the same size, so R is the same. And they all have pretty much the same mass, about 400 grams. So for all these three shapes, M is the same, R is the same, and I'm going to start them rolling down from the same height. And what's going to happen? So these are the possible answers. Pick yours. A, B, C. Oops. That's not right. I don't know what happened. It stopped. So let's pick your answer, start again, because I'm going to switch again to the camera. Appearances can be deceptive. It looks like it's bent, but it's not. So everybody has to press by now something. What happened after this doesn't matter. Yeah? But you could clearly see what had happened. Which came first, which came second, and which came the third. And everything, again, is based on the same reasoning. We already have it solved for all of them. For all three shapes, the problem has been solved. Let's see what you said. Number one. Well, you know if you're right or wrong. So the work which is supposed to be done is no different at all from what we had written just like 2 minutes ago. So the solution, of course, is exactly the same. And the only variable which does matter is that capital C, a form factor, if you want to call it a shape factor. If the C is large, that makes the final speed small. If the C is small, that makes the final speed large, right? So because they kind of inversely proportional with the square root, but anyway. And more inertia means, well, it should take longer time to travel the same distance. And which has the largest inertia? Well, coefficient C equals 1. For a hollow cylinder, the coefficient, the next is 1/2 for a solid cylinder, and then the sphere. So now the sphere wins. Any questions? All right. Now let's do some actual problems. So this is a situation when it rolls horizontally. Well, again, having no resistance and having no friction, two different things here. when I push on it, the friction makes it spin. Otherwise, it wouldn't. Right? This force can't make it spin. It has no torque relative to this axis. But in an ideal world, if there is no deformations, if ideal circle, ideal surface, if I gave it a push, it should have been traveling forever like that. No resistance. But in this situation, what's going to happen if we want to stop it? Well, first we can imagine that we actually just lift it, but it keeps rolling. Does it mean we stop it? Well, in this situation, not yet. We also have to kind of stop it from rolling as well, which means we need to take away from this object both kinetic energies. Kinetic energy due to translational motion and kinetic energy due to rotational motion. So when it stops, this is 0, and this is 0. And in this situation, this is not 0, which is what? Which is 2 meters per second. And this is not 0, which is what? Well, that's got to be related. They related. No slipping, which means that should be equal to initial times divided by the radius, which is 2 divided by the radius. Now, do we know the radius? No. So what do we do? These are only options in life. So we have to believe it's solvable and see if we can simplify. First of all, kinetic energy, again, mv squared over 2 plus rotational inertia omega squared over 2. That's not a problem. 5. That's not a problem. 2. That's initial kinetic energy squared over 2 plus. Now we start thinking, okay, what is it? A ball. The form factor, 2/5. Mass, okay, 5. Radius squared, we don't know. Well, we have to write something, and in math, that's a variable. It's a placeholder for a number. Now, well, this expression has at least one number in it, so let's use it. That's got to be 2 meters per second divided by the radius. Everything has to be squared, and that has to be divided by 2. And now, I wouldn't say miracle had happened, because it's not a miracle. Yeah, it's pure math. Turns out sometimes things not known, but they don't matter. The radius squared getting canceled, and that gives us what? 10 joules from this, and here 5 over 5, 2 over 2, 4, 14 joules. That's the initial kinetic energy. And, well, final is 0, so kinetic final minus kinetic initial, that gives the amount of work which has to be done. 0 minus 14, negative 14 joules. Sometimes, what I'm not sure about, sometimes on a web assign or in a textbook, they say amount of work, but they mean magnitude, so maybe 14. It might be not clear, but that's why we have several trials to You know, if negative 14 doesn't work, 14 should work, or vice versa. Not sure. Okay. Now, so we've analyzed a situation with an object rolling down. Let's now roll it up. What's going to happen? A cylinder. Again, we know it doesn't matter. We always can solve it for any shape. We just have to use the moment of inertia in a general form with the form factor in it. Eventually it stops here. So here, final speed is 0, and because the rotational motion is coupled due to friction between this ball and or a cylinder and the ramp, the final angular speed is also 0. What about the initial? So the initial speed equals 3 meters per second, and the initial angular speed equals 3 divided by the radius. And now we know it shouldn't matter. Okay, so how far does it travel? Well, how far means this distance. But it's easier to calculate the final height first. That's a 30 degrees angle. That's the height. How can we relate them? We just did it before. It doesn't matter if it goes from up to down or from down to up. Still, we can apply the same law of conservation of energy. So now, if we measure the height from the lowest point, the initial potential energy is 0, but the initial kinetic energy is equal to 2 times 3 squared divided by 2 plus. Well, that's a cylinder, so let's write 1/2, a solid, not a hollow, a solid cylinder, 1/2, times mass, 2 squared, times angular speed squared, which is supposed to be equal to this, and times the radius squared, yeah. 1/2, I will rewrite it. 1/2 times mass times the radius squared, and now angular speed, which is equal to the linear speed divided by the radius, and everything squared, and that's divided by 2. And that has to be equal to the mass, which is 2, and as we know, it's going to cancel anyway, times g, which is 9.8, times height we're looking for. And again, we can see, we can cancel this. So turns out the height will be equal to 9 plus 2 and 2, 9 over 2, 4.5. Check my calculations. You know I make mistakes as anybody else, times 10. $13.5 divided by 20. Oops, it's too dark. You can calculate it. It's 13.5 divided by 20 meters. But if we want to calculate the distance traveled, that's what we called on the exam the length of the hill. We just have to use the right angle triangle. In this situation, this actually should be equal to this times sine of 30, divided by sine of 30, divided by sine of 30, which is 2 times 13.5 divided by 20, or 1.35 meters. All right. Any questions? I'm going to do one more slide. I want to solve this problem using forces and torques, so you would see how much harder it is. So that's the best approach. But that's going to be on Monday. And on Monday, we start the new topic. Yes? S. Yeah, you can take everything back. Yes.
Okay, so we had snow day, snow days. Do you remember the beginning of the semester?
Yes.
And on Monday and Tuesday, lab was canceled, and then we had to replace it by making it up on another day.
Yes.
But I wasn't able to fit it into my schedule, so I just wanted to ask if you were going to have a makeup lab day.
For everyone who had a missing lab due to snow or something else, I will set up a makeup lab by request sent like a week before. You should send me an email about a week. No, I will forget by that time.
Okay.
The makeup labs, all of them taking place during the last week of the class.
Okay.
So, like on Friday before the last week, on Thursday before the last week, you should send me an email and I will tell you where. I don't know where the lab's going to be set up. Probably it's going to be in a different room or maybe else. So, like 10 days before the last day of the class, you should send me an email.
Okay. No problem.
So you need to make up that specific lab. You should say which lab do you want to make up.
Okay.
And it's going to be set up for you.
Thank you.
I have a question about the test, the exam.
About the grading?
About the grading, yeah. How does it go about grading? Like, I just put it in the calculator wrong, and I got off like a full point. And then also, that answer messed up my next part. But then you took off another 1.5 points.
I didn't take anybody's points.
Well, the grading system on this exam.
Well, first of all, it's not about the system. It's about the application of the system,
Yeah.
which
But
is
I
about
showed all my work.
how TF's graded. So
I should talk to a TF?
no, you should talk to me.
Okay.
They're just two different things. They can't regrade it. I can. But I need to spend some time to look at it, to think through it. And in that case, so we need to find more time to meet. So when?
Could we come like during office hours?
The best time is office hours.
Okay, that's fair.
If you can, if it's available for you, that's the best solution.
Okay, we'll see them.
If you cannot and you want to talk, in that case, we should find, a different arrangement.
Okay. All right.
Can you come to office hours?
I can come like next Friday.
Perfect. That fits.
right.
No problem. Just a second, I need to shut it down.